Hi everyone, welcome to today's video on solving equations involving fractions. When solving equations with fractions, for addition or subtraction of fractions, finding a common denominator simplifies the process and allows you to combine terms more easily. Finding the lowest common denominator is the best, but if you can't do that, any common denominator will suffice, and you can always reduce the fraction later. And for equations with fractions on both sides of the equal sign, that forms a proportion, you can cross multiply to efficiently eliminate the denominators and simplify the equation. So now let's go over a few examples. So for question 1, we have x over 3 equals 4, so we want to get x by itself. So since we're dividing by 3 on the left, to get the x by itself, we need to multiply by 3. So multiplying by 3 on both sides gives us x equals 12. So x equals 12 is our answer. For question 2, we have fractions on both sides, so we have some sort of proportion. So we can cross multiply so we can get rid of those denominators, and then we can simplify from there. So when cross multiplying, you want to multiply the numerator of one fraction with the denominator of the other, and you're going to set them to equal each other. So we get 4 times y plus 1 is going to be equal to 3 times 2y minus 5. So now we can distribute and simplify. So 4 times y gives us 4y, and 4 times 1 gives us 4. And that's going to be equal to 3 times 2y, so 6y, and 3 times negative 5 gives us negative 15. Moving the 6y to the left and the 4 to the right, we get 4y minus 6y equals negative 15 minus 4. So we end up with negative 2y equals negative 19. So to solve for y, we need to divide both sides by negative 2. That cancels, and we end up with y equals 19 over 2. For question 3, we are adding, so we need to have the same denominator. Luckily, the denominators are already the same in this case, so all we have to do is add the numerators. So z plus 3z is equal to 4z. So 4z divided by 4 is equal to 7. These 4's cancel out since we're multiplying and dividing by 4, and we're left with z equals 7. For question 4, we're not so lucky. We're adding, but we have different denominators, so we need to find a common denominator so that we can add the fractions. If we multiply x over 2 by 3 over 3, so the denominator of this other fraction, and if we multiply x over 3 by 2 over 2, which is the denominator of this fraction, we can get a common denominator of 6, and that allows us to add the fractions. So we get 3x over 6 plus 2x over 6 equals 5. Adding those together, we get 5x over 6, or 5 over 6 times x, and that equals 5. So to get x by itself, we need to get rid of this 5 over 6. Since we're multiplying x by 5 over 6, to get rid of it, we need to divide both sides by 5 over 6. So if you're dividing by 5 over 6, these cancel. And over here, dividing by 5 over 6 is the same thing as multiplying by 6 over 5. So now we get x is equal to 5 times 6 over 5, but these 5's cancel because we're multiplying by 5 and then dividing by 5, so we get x equals 6. For question 5, we are subtracting, so we also need a common denominator, and a common denominator between 5 and 3 would be 15. So we can get that by multiplying the y minus 1 over 5 by 3 over 3, and by multiplying the y plus 2 over 3 by 5 over 5. So from that, we get 3 times y minus 1 over 15 minus 5 times y plus 2 over 15, and that equals 4. Now we can distribute and simplify. So we end up with 3 times y, which is 3y, and 3 times negative 1, which is negative 3. And then negative 5 times y gives us negative 5y, and negative 5 times 2 gives us negative 10. And this is all over the same denominator of 15, and this equals 4. Now we can collect like terms and simplify in the next line. So 3y minus 5y is going to be negative 2y. And negative 3 minus 10 is going to be negative 13. And this is over 15, and that equals 4. To get rid of this dividing by 15, we can multiply both sides by 15. So these would cancel out, and what we're left with is negative 2y minus 13 is equal to 60. To get rid of this minus 13, we have to add 13 to both sides. So we get negative 2y is equal to 73. And then to isolate y, we need to divide by 2 on both sides. So we're left with y equals negative 73 over 2. And now I'm going to clear this to make room for question 6. Question 6 is the first time you're seeing a variable in the denominator. When you see a variable in the denominator, you need to first make sure that the denominator cannot equal 0. So the first thing you need to do is set some sort of criteria. So if the denominator cannot equal 0, then x cannot equal 0. And the reason why the denominator cannot equal 0 is because you cannot divide any number by 0. When you divide a number by 0, we call this undefined. So if we end up solving this and it gives us x equals 0, we know that it cannot equal 0 because of our prior criteria. So you need to do this at the beginning before you solve. If you see some sort of variable in the denominator, you need to first establish some sort of criteria where the denominator cannot equal 0. So I'm just going to keep this here to remind us of it later. Now we can solve like usual. So to get this x out of the denominator, we can multiply both sides by x. When we multiply by x on both sides, we end up with this canceling, and we get 5 equals 2x. To get rid of this multiplying by 2, we can divide by 2 on both sides. These cancel, and we're left with x equals 5 over 2. Now that we have our answer, we just need to make sure that it holds true with our criteria. So our criteria says that x cannot equal 0. Since 5 over 2 is not 0, we are good to go. So x equals 5 over 2 is our answer. Let's do some more examples. Here we have 3 divided by y plus 1 equals 6. So we have a variable in our denominator, so we need to make sure our denominator cannot equal 0. So we're going to make our criteria here. Y plus 1 cannot equal 0. So we need to figure out what y value we cannot have. So to solve for y, we need to subtract 1 from both sides. When we do that, we get y cannot equal negative 1. And the reason why is because if we plug negative 1 back into our equation, we get 0 in the denominator, and we cannot have 0 in the denominator. So now let's solve our equation, and then we'll check it with our criteria later. So to get the y plus 1 out of the denominator, we can multiply both sides by y plus 1. This would cancel, and we'd end up with 6 times y plus 1. So from that, we get 3 equals 6 times y plus 1. To get rid of this 6, we can divide both sides by 6. Those would cancel, and we get 3 over 6, which is the same thing as 1/2, is equal to y plus 1. To get y by itself, we can subtract 1 from both sides. These would then cancel, and we get y is equal to 1/2 minus 1, or negative 1/2. Now we need to check our answer with our criteria. We said y could not equal negative 1. And since this is negative 1/2, we are okay. So y is equal to negative 1/2. For this question, we have 2 denominators with variables in them. So we are going to have 2 different criteria. So for the first one, we have to set x plus 1 cannot equal 0. And that means x cannot equal negative 1. And for our second criteria, we need to set x minus 2 cannot equal 0. And therefore, x cannot equal 2. So these are our 2 criteria. Now remember when we have some sort of proportion, so when we have fractions on both sides of the equal sign, oftentimes we can use cross multiplication to simplify. So that's what I'm going to do. So that gives me 2 times x minus 2 is equal to 5 times x plus 1. Now I'm going to distribute and simplify. So 2 times x is 2x, and 2 times negative 2 is negative 4. And that's going to equal 5 times x plus 5. I'm going to move the 2x over to the right and the positive 5 over to the left. So when I do that, the positive 5 turns into a negative 5, and we have our negative 4, and that's going to equal 5x, and then that 2x turns into a negative 2x. So solving, we get negative 9 is equal to 3x, and to get x by itself, we can divide by 3 on both sides, and so we get x is equal to negative 3. Now we just have to make sure it's okay with our criteria. So if x is equal to negative 3, it is not equal to negative 1, it is not equal to positive 2, so we are good. For question 9, we have a variable in both the numerator and the denominator, but we only need to make a criteria for the denominator, and that's because the denominator cannot equal 0. We can't divide by 0, but it's okay to have 0 in the numerator. If there was a 0 in the numerator, 0 divided by anything would just be 0, so we don't need to make a criteria for the numerator. So first, let's make our criteria. We have x plus 2 cannot equal 0, so x cannot equal negative 2. Now we can solve as per usual. So to get this x plus 2 out of the denominator, we need to multiply both sides by x plus 2. So then this would cancel, and we get 3x equals 4 times x plus 2. Now we can distribute and simplify, so we get 3x is equal to 4x plus 8, and I'm going to move this 4x over to the other side, and when I do that, it becomes negative, so 3x minus 4x is going to give us negative x, and so negative x equals 8. So to get x by itself, we need to divide by negative 1, so doing that to both sides, we end up with x is equal to negative 8. And now checking this with our criteria, x is equal to negative 8, so we're good. It's not equal to negative 2. For this next question, we have a proportion again because we have two fractions. The variables are only in the numerators, so we don't need to come up with any sort of criteria. And since we have a proportion, I'm going to solve using cross multiplication. So we end up with 3 times 2x plus 3 is equal to 5 times 4x minus 7. So now all I have to do is distribute and simplify. So 3 times 2x gives us 6x. 3 times 3 is 9. And that's going to be equal to 5 times 4, which is 20x. And then 5 times negative 7 is negative 35. So moving this 6x over and this negative 35 over, we get 9 plus 35 is equal to 20x minus 6x. 9 plus 35 is 44. And that's going to be equal to 20x minus 6x, which is 14x. So to isolate x now, all we have to do is divide by 14 on both sides, and we get x is equal to 22 over 7. For our next question, we have a fraction within a fraction, but we don't have any variables in either of the denominators, so we don't need to come up with a criteria. If there was a variable in this denominator, we would have to come up with a criteria, because if that were to equal 0, we would have an undefined answer. So anytime you see a fraction and it has a variable in the denominator, you need to make sure you set some sort of criteria where that denominator cannot equal 0. So to isolate this numerator portion, I need to get rid of this dividing by 3. So to do that, I'm going to multiply by 3 on both sides. This would then cancel, and now I'm left with x over 2 plus 1 is equal to 15. I'm going to move this positive 1 over where it turns negative, and so I end up with 15 minus 1, which is 14. To get rid of this dividing by 2, I'm going to multiply by 2 on both sides, and so I end up with x is equal to 28. For question 12, I have another fraction within a fraction. There's no variable in this denominator, but there is a variable in this denominator, right? Because this is 1 divided by this entire portion. So we cannot let this portion ever equal 0, because if it equals 0, then we have an undefined answer. So our criteria is going to be 2x over 3 plus 1 cannot equal 0. So we have to solve this. So then we get 2x over 3 cannot equal negative 1. 2x cannot equal negative 3 because we multiply both sides by 3. And then x cannot equal negative 3 over 2. So now when we solve this, we need to make sure x does not equal negative 3 over 2. So to get this out of the denominator, I'm going to multiply both sides by 2x over 3 plus 1. Then that would cancel on this side, and I would end up with 1 is equal to 4 times 2x over 3 plus 1. To get rid of this 4, I'm going to divide by 4 on both sides. So that would get rid of the 4 on this side and cause a 1 over 4 on the other side. So now we have 1 over 4 is equal to 2x over 3 plus 1. Now we can't get rid of this right away because if we multiply by 3 on both sides, then this 1 also gets multiplied by 3. So we want to get rid of this first. So to get rid of the positive 1, we're going to subtract 1 from both sides. So subtracting 1 on this side cancels it out, and then we end up with a negative 1 on that side. Now we can get rid of this dividing by 3 by multiplying by 3 on both sides. So we can multiply by 3 over here and multiply this by 3 over here. So these would cancel. And to get rid of this multiplying by 2, we can divide by 2 on both sides. So if we divide by 2 on both sides, it would cancel here, and then we end up with this. So now we would have x is equal to 3 times negative 1 plus 1 over 4 divided by 2. So now we just have to solve this. So that would be equal to 3 times, and now negative 1 plus 1 over 4. We need a common denominator, so I'm going to multiply negative 1 by 4 over 4. So that's going to give me negative 4 over 4 plus 1 over 4, all divided by 2. To simplify this further, now we have 3 times, and now 1 minus 4 is negative 3, and it's all over 4. And then we're going to divide this all by 2. And now this is going to be equal to a positive times a negative. So our answer is going to be negative. 3 times 3 is 9. And it's going to be 9 over 4. And we're dividing all of this by 2. And when you're dividing by 2, that's the same thing as multiplying by the inverse or the reciprocal. So 1 over 2 or 1/2. Now when you're multiplying fractions, you multiply the numerator with the numerator and the denominator with the denominator. And so we end up with negative 9 over 8 as our answer. Lastly, for question 13, I want to move all my u's to one side and keep my constants on the other side. So I'm going to move this u minus 3 over 4 over to the other side. So now I have negative 2 equals 3u over 2 plus 2u plus 1 over 5 minus u minus 3 over 4. Now I need to find a common denominator between all three of these numbers. I'm going to start off with the bigger numbers first and then hope that it is also a multiple of 2. So 5 times 4 gives us 20. 20 is the same thing as 2 times 10. So 20 is a common denominator for all three of these. Now I'm going to multiply each of these terms by 1 to change their appearance so that they can have 20 as a denominator. So to get the denominator to be 20 here, I need to multiply it by 10. And since I don't want to change the value of this 3u over 2, I need to multiply by the same thing on the top, so that I'm essentially multiplying by 10 divided by 10, which is 1. To get 20 in the denominator here, I need to multiply 5 by 4. And since I want to multiply this entire thing by just 1, I need to make sure the numerator is also 4. So I'm multiplying by 4 divided by 4, which is 1. And for this one over here, in order to get 20 in the denominator, I need to multiply by 5. So what I do to the bottom, I must also do to the top, so that I'm just multiplying by 1. Now I'm going to rewrite this in the next line. So I get negative 2 is equal to 30u over 20 plus 4 times 2u is going to give us 8u's. And 4 times 1 is going to give us 4. And that's going to be over 4 times 5, which is 20. And now we're subtracting because of this negative sign here. And 5 times u will give us 5u. And 5 times negative 3 will give us negative 15. And this is all over 4 times 5, which is 20. Now that we have the same denominator, we can simply add these together. So now we get negative 2 is equal to 30u plus 8u plus 4 minus, and remember we're subtracting this entire portion, so this negative sign needs to be applied to each of these terms. So negative 5u, and negative times a negative will make a positive 15. And all of this can be over the common denominator of 20. Now to get rid of this dividing by 20, we need to multiply both sides by 20. So when we multiply both sides by 20, this cancels out, and we get negative 40 is equal to this top portion, but we can simplify it. So collecting our like terms, we have 30u plus 8u minus 5u. So 8 minus 5 is going to be 3u's, and 3u plus 30u is 33u. And now for our constants, we have positive 4 and positive 15, which would give us positive 19. So we have negative 40 equals 33u plus 19. To get rid of this positive 19, we need to subtract 19 from both sides. So that would cancel on this side, and then negative 40 minus 19 would give us negative 59. So negative 59 equals 33u. So now to get u by itself, we need to divide by 33 on both sides. And we end up with u is equal to negative 59 over 33. And since that fraction cannot be reduced any further, that is our final answer. I hope this video helped you guys. Let me know what you want to see next, and I will see you in the next video.